So our objectives tonight: welcome, opportunity for public comment. If anyone in the public wants to say anything about anything on the agenda. Ashley didn't raise her hand, so I guess it's a no. Then we'll do updates. We're going to talk about pumping capacity analysis. We'll accept the notes from our last meeting. Then, as I said, go through major findings, and then we'll be done by 6 o'clock. We've been following this roadmap since we started meeting in January, and we started off down at the bottom talking about the capital improvement program process and how we prioritize projects. We got your input on project prioritization criteria. In February, we talked about the scorecard from the last water master plan, where the board is on those many metrics, and talked about some things that might be missing or that could be changed in that scorecard. And then we finalized the prioritization methods that we talked about in the previous meeting. In March, we presented the results of some condition assessment, in particular with regard to the extensive condition assessment we did on reservoirs. And we talked about climate resilience, and there was an update on the PFAS project, right? So detections of PFAS in some of BWS's sources, and what does that mean, and what are some of the plans to deal with that? In April, we talked about water demand projections out into the future and broached the notion that overall island-wide water demands are likely to decrease in the future, even with population growth, largely as a result of expected reductions in per person consumption. So we went into the explanations of all of that. We talked about potential additional supplies, including recycled water, had a little video on potable reuse, and then also talked about the long-term plan for PFAS. And so here we are in July, and what we're going to do is go through the pumping capacity analysis, and as I said earlier, major findings from all of these different evaluations. So kind of recapping those things. So any questions about where we're headed on the roadmap tonight? Okay.
Yeah, I don't really have a lot to give you an update on. We'll start off maybe with Red Hill. What's really becoming more evident, and we've since written to the Department of Health and the US EPA, is the findings of PFAS, or forever chemicals, on the Red Hill property. The Navy's reports indicate detections at many different locations from various levels, just below the reporting limits to well above it. What we're finding, since we've embarked on the effort to install our own monitor wells, and this is not on Navy property, this is outside of Navy property. And we've drilled some recently that we detected pretty significant levels of PFAS chemicals, which we think might be related to AFFF firefighting foam. In particular, a monitor well that we drilled at the old animal quarantine station in Halama Valley. It's run by the state of Hawaii. That's detected PFAS, and that's right adjacent to Red Hill property, on the Halava side of the Red Hill property. Then on the other side of the valley, at the Mauna Loa golf course, and mahalo to the golf course to allow us to install a monitor well there, right along the main road that goes into Mauna Loa Valley, we detected pretty significant levels of also PFAS that's related to firefighting. We think it's related to firefighting foam. Another monitor well we installed, and thank you to the Department of Parks and Recreation at the Halava District Park, also is showing signs of PFAS contamination detections there. So our letter that we wrote to the U.S. Navy, to the Department of Health and to the U.S. EPA just raises our concerns about these detections from very low levels to very high levels on Navy property and on property on both sides, in Mauna Loa Valley and Halava Valley side, all the way into Aiea. So our concerns, we haven't heard a response from them. I did meet with them in Washington, D.C. for a little while just to raise their awareness about it. They're working on a response, but we haven't received anything yet. So Red Hill, the tanks are getting cleaned and cleaned, and I think they're being emptied. The pipelines they're taking out the residual fuel from the pipelines. There are about 10 miles of pipelines that connect the tanks to the Pearl Harbor. But the issue of petroleum, maybe the issue is moving on to also concerns about forever chemicals that were used potentially at the Red Hill property and its impact on the environment and on the groundwater. So that's a challenge. We'd like to maybe give you an update maybe at a future SAG meeting on this. We'll be doing something at our board meeting later this month, just to make you aware. We have more questions and answers about this. I'm going to be starting the outreach to let people know about potential increases in our water system facilities charges that was briefed to this stakeholder advisory group earlier, and start doing the outreach with developers or others. So if you have anybody that you'd like us to do that presentation for, please let me or Kathleen know. I'd be glad to do it. I just got an invitation to do something for the operating engineers for the hotels next month. Please, this presentation that's coming up on this information, we really kind of struggled with it to how to make it really understandable to anybody, but please take the time to ask questions freely too. And mahalo for coming out and being committed to help our community with our long-term plans for water.
What do we want to do today? Want to focus in on informing you about the pump capacity analysis that we've done. We want to present the draft major findings that follow from the past 2 years of evaluations and hear from you about whether those findings resonate and if there's any other items that you feel we need to evaluate as we move into the next phase of the Water Master Plan development, which is the development of the capital improvement program. So as you're hearing report outs from Bill, from Carl, keep that question in mind. Are we missing anything? Are there unanswered questions that you have? And are those questions things that we can address in the Water Master Plan process? So these findings may result in specific recommendations in the Water Master Plan. Those recommendations will inform the development of the capital improvement program and other initiatives, potentially operational changes, other studies, evaluations, those types of things. So that's where we're headed.
Yep, so we're going to run through the pumping capacity analysis. So what is that? What we're really looking at here is confirming the ability to move water where and when needed. So last meeting we talked about source. So that's really the overall, are we able to get water out of the ground and into the system as much as we need? This evaluation is more about once it's out of the ground, how do we get it moved where it needs to be? Do we have the pumps we need to be able to keep all the pressure zones supplied? So how do we do this? The first step is looking at BWS's water system standards. So these are a base level standard that set how the water system is designed. So really they're intended for development. When we start out with a new area or when we're adding significant capacity to an area, there are standards that say things like, what is the fire flow for this area? How many pumps do we need above, say the maximum day demand? What does the reservoir volume need to be? These standards. So we start there. And what those water system standards do is they make sure that we are, yes, providing the pumping capacity that's needed and a little bit more, making sure that it's a bit conservative to make sure that we always have adequate pumping capacity even when some things go wrong. So I'm going to lead with the takeaway. Overall, the currently installed system works. It is adequate to serve existing demands. We're going to get into some details here, but overall, that's the main takeaway. But now we're going to do some quick kind of definitions. All right, so again, how do we do this evaluation? We look at all of Board of Water Supply has 110 different pressure zones. So that's a section of pipe that all sits at the same pressure of water in it. And there will be reservoirs, one or more, generally more, reservoirs in that zone. They'll be right at the very top of it where the water level sits. And then it's all connected to the distribution system that comes to everybody's houses. And then usually at the bottom of it, there's a pump that pumps into that system. So the pump brings the water into the system up to the elevation of those tanks and keeps it all pressurized. So we take that as one unit and look at that and say, okay, just this zone, how are we looking? So how do we look at it? Definition here, firm pumping capacity. So what does that mean? Pumping capacity is the size of the pump station, right? How many gallons per minute it can pump. Firm pumping capacity is a term we use. It's how much water the station can pump even with the largest pump turned off. So what that means is if you have, say, 3 pumps at a pump station, you assume that one of them is turned off and you assume the biggest one is turned off. And the reason for that is that gives you the conservative value of what that pump station can pump. So a little figure trying to point this out here. If this is a whole pump station, we have 2 smaller pumps and 1 larger pump. The total capacity is all 3 of those added up. The firm capacity is just the 2 smaller ones, and we assume the gray one here is turned off. Then we take that firm capacity down here. That's so many gallons per minute. We subtract the demands in that zone. So how much water is being used in that zone from customers or that's going to other zones. And then the result of that is either the surplus if it's positive or a deficit if it's negative. And then we talked last time about demand, so we want to do a little bit of a comparison of the two. What is the difference? Again, demands are looking island-wide at source. So what we talked to you last time, DBET is projecting a 3.6% population increase. That's over about 30 years. It's 2050 that they go out to. Over a similar time, not exactly the same, when we're looking through 2055, we're seeing about a 13 to 14% reduction in gallons per capita per day, gallons per person per day demands. So population's going up 3%, but each person we think is going to use about 13% less based on the trends we're seeing. So we see overall decreases. Again, that's looking island-wide at the source coming out of the ground. Now we're looking at pressure zone pumping capacity. The caveat here is population is going to shift around the island. Not everybody's staying in the same spot, especially when it comes to the transit-oriented development and other large developments. So when looking at those, we're looking at local shifting of demands of up to about 28 million gallons per day. So that's not new demands, but it's demands moving from one place to another. Really what it comes down to is some zones demands are going to decrease and some are going to increase. And so we want to know what those look like. This all is somewhat uncertain, so I want to make sure we're bounding that uncertainty. What could that be? DBETs may not fully account for all those potential developments. You know, they know what they know, but they don't know what they don't know. There are potential future things coming in that we just can't see at the moment. The actual reductions in that per person demand may be more or less. We might not be right on the money with those. And then a big one is the timing of the development. So if that development happens at the back end of the 30 years, maybe it's not a big deal. Maybe we've saved enough water that we already have it. If it happens at the front end, we don't. So that timing really makes a pretty big difference. So we're looking at a projection of the state of the system 30 years out. And the reality is we're just going to have to shoot for where we think we're headed and then keep monitoring and reevaluating. So what did we come down to? Here are the areas with the highest pump capacity needs. Overall, depending on, I talked about the standards, depending on exactly which standard you're using and how you're looking at it, we see right now between 16 and 40 of those 110 zones that have some sort of need, but they're generally really minor. You design it for meeting the water system standards, and then over time, things tweak a little bit. So we see several of the zones that do have some need, but generally they're small. These needs where they're more significant, how do we get around it? It could result in additional supply. That's one way to do it. Additional pumping, if you have supply that you can bring from another place, or other projects, you might need pipelines, valving, things like that to be able to move the water around. Currently, the biggest need is over in Waianae, that zone. We see about 2.5 MGD of potential need there. Again, that doesn't mean can't serve water there now. It means we're not, based on the standards, we're not exactly where we'd like to be. That has a lot to do with actually decreasing supplies out there, not so much either growth or changes in how we can move water out there. It's that more water is going to need to be moved out there over time to offset some dwindling supplies. The rest are pretty flat, but then we'll see when we layer in the transit-oriented development over the top of it. So these relatively large developments, mostly on the south side of the island. There's two zones that really float to the top, Metro 180, and that's this zone here. So this is most of the west side of town, basically Diamond Head out towards Halava. And that one we see all added up about a 14 MGD increase. Fortunately, that's a big zone, so it's actually, it's only 19%, even though that's a big number. And then the other one is Pearl Harbor 277, that's this one up here. And there is about 2.5 MGD of increase there. I think that's the Aloha Stadium area where we see that coming in. So that's a smaller zone, so it's a big need, but it's a smaller total volume.
So for the Waianae area, and we talked about supply is low. So when you say supply is low, does that mean it's because we need to drill more wells perhaps? Or does that mean even if we drilled more wells, the level of water that's available to be tapped into is, becoming depleted?
What's actually happening on the Waianae coast and along the Waianae mountain range is over time there's less rainfall, so there's less recharge. So actually capacity is not increasing there, maybe decreasing over time with lower rainfall rates. We're actually petitioning the Water Commission to designate the whole Waianae coast as a groundwater management area, because it is, we think it's kind of reaching capacity, and we think there needs to be regulation. For Board of Water Supply, we really are aware of this, but there's also, other users of water in that area, or developers that want to drill their own wells. So for the Waianae coast, what's happening to make up the needs of Waianae, the whole coastline, their sources, water sources, wells and tunnels and shaft is not adequate to meet the current demand. So right now about 55-60% of the water demand is being met by water taken from the Waipahu Eva area and pumped along Farrington Highway through a 24-inch transmission main. And that's sent along the coastline to meet the demands of the coast right now. So this is what we're going to have to evaluate. How do we provide the additional demand? Also, there is discussions too about trying to restore traditional streams in the Waianae coast that have largely become dry over time because water use and groundwater use. So those are all some of the challenges. We are right now working on a watershed management plan update for the Waianae coast, and Some of the folks here tonight from the Water Resources Division and Communications Office have been out there to meet with the community, to listen, to understand what the concerns and priorities are.
So you started off by saying the last time on our trip, our transit here, that we talked about pumps getting water out of the ground. So you have those kind of pumps, and then now we're talking about transmission lines, pumps that provide the volume and the pressure. And it seems like a third category of pumps would be redundancy or emergency response pumps. So as long as we're on the topic of pumps, maybe you'd like to pump more information out.
You're punny. So yeah, that was the firm capacity. That's where you have at each station, you have one pump that's spare, that's there ready to kick on if ever needed, if one of the other ones goes out. When you're thinking about emergency response, really that's where we depend on tanks. So the reservoirs are what store the water for fire flow. You generally aren't using pumps for that because it's really high flows in a short period of time. You have your water sitting in the reservoir there ready to go all the time. So that's kind of from an emergency response perspective, that's where that flow comes from, is from the tanks. But yes, there is, every pump station has, at least the way we plan it, one extra pump that is there and ready to go. And all of these blur the lines a little bit. We talk about getting water to the ground versus moving it. A well pump both takes the water out of the ground and puts it into the system. So it's a little bit of a caveat on how you add it up. There's a permit on how much water you can take out of that aquifer in a year. So you're limited there, but then there's also a limit on if you kick all the pumps on, how much right now, this minute, this hour, can you get out? So those are both numbers that we got to keep an eye on and make sure that they are able to cover both long-term over the course of a year and short-term.
With regard to how much you can take out right now as opposed to allocation on an annual basis, is the governing metrics on that deal with salinity, or how does that factor in?
So this might be, Ernie, tell me if I get anything wrong here, but generally you're limited on just volume. That said, BWS has looked at water quality chlorides at many of their wells and has set, in some of those wells, their own limits on where they want to be, just based on looking at salinity and making sure we're managing that over the course of the year. When do you want to get that volume out without making sure you don't impact it?
So the Water Commission really manages how much water can be withdrawn from the ground through wells on the island, almost the entire island of Oahu, except the Waianae coast. And that's the last area that is not a groundwater management area. So with that, the Commission's looking at how much water can be withdrawn without damaging the resource, the freshwater aquifer, make it unusable. And one of the key things that they look at is the saltiness of the water measured by chlorides, what we call chlorides. So they want to keep the water as fresh as they can and not have us overpump, because basically much of our aquifer on Oahu is fresh water floating on salt water in the cracks and crevices of the lava rock below us. So if you overpump, you could draw some of that salt water up or inland from the shoreline. So they issue water use permits for us for most of the island, and we have to stay within what the permit allows us to withdraw.
Haleiwa is kind of at the low point of two mountain ranges, and the water tends to go down there. Thank you, Newton. But so when developers come along, they're going to generate X amount of wastewater. And they always go, oh, don't worry about it. Department of Health is going to make everything okay. But I don't know how geologically oriented the Department of Health is. And you've got these different water agencies. A lot of people on the North Shore worry about too much wastewater. They don't want it in the ocean. They don't want it in the aquifer. So how are we going to get rid of it, kind of thing? And they say, oh, well, we don't want you injecting it down, no injection wells. So you got all these good ideas about what you shouldn't do, but as the capacity increases, or the desire or the demand to get rid of that water, are there any good answers about that?
Yeah, we talked a little bit about alternative sources, right? And we talked a little bit about water reuse a couple meetings ago. And so I think that's a potential option, is to look at localized water reuse, where you're capturing that wastewater, treating it, and either using it for non-potable purposes, agricultural irrigation, things like that, or treating it to a greater level and using it for potable purposes. So I think as collectively we all look out into the future and how those demands change and what the sustainability pressures are as we face into the future, those are the types of alternatives that will need to be looked at going out into the future, Bob.
And when these developers create their own wells, what kind of standards do they have to follow? Is that established by the Board of Water Supply as far as the type of equipment and when they operate, when they test it, and what are the limitations when they create their own wells, so that way they're not running rampant with utilizing the resource?
Again, the well construction, like when you drill the well, how you build it, that's regulated by the Water Commission. Kaleo, correct? Okay. So they have to get what they call a well construction permit. Then when they want to put a pump into the well, they'll need to have a second permit called a pump installation permit, which needs to get reviewed and approved by the commission. Commission has well standards that they require developers of wells to follow. We have to follow them too. We also have our Board of Water Supply water system standards to follow. So those are the two ways to regulate drilling of wells. Although there could be situations where somebody just drills a well without getting a permit, but hopefully that's few and far between. But they would be subject to a potential enforcement action by the commission if brought before the commission or to their attention.
Okay. Any other questions on the pumping?
I just want to say wells are an important way to access the water resources, the underground aquifers. But when a person stops using the well, it's really important that those wells are properly sealed. If not, they become a pathway from the ground, shallow ground, to all the way in deep into the aquifer to carry contaminants potentially into the aquifer. Or the wells could be a situation where freshwater resources are wasted or contaminated by more saline water or contaminated water moving through the well into different parts of the aquifer. So sealing the wells is very important too.
What's the impact on pumping capacity analysis with Red Hill, which we started talking about, with PFAS we're talking about, with traditional agricultural uses that communities like ours on the windward side and the west side are trying to restore? And then with the whole issue of septic systems, everybody's got to get off of cesspools by 2050 and convert. And we have no idea convert to what. Seepage pits, still putting waste into the ground. And a recent conversation we had with Ernie folks about the Department of Health trying to push this responsibility of. So another issue that I've been wondering about, we're looking across the nation, across the world, at data centers. What are going to be the demands here on Oahu as far as water for something like data centers?
Red Hill and such. I'm going to put all those other things, contamination events, things like that. Yes, had a big impact on the pumping evaluation. That was probably the biggest change from 2016 when we did it until now, is the removal of Halaba shaft from that zone. And that had to be made up by other sources. So yes, that had a quite large impact. We're still okay there in the Metro 180 zone. But it's kind of, it took the slack out of the system essentially, from where we were at. And basically that's true with the other source impacts too, whether leaving water in the creek, all these other things are limitations in water that can come out of the ground in one way or another. So each one of those is not necessarily a big deal, but once you start adding them all up, you get to the point where you remove the slack from the system, and you get to the point where you say, all right, now it's time we need some more room.
Maybe instead of the word slack, I might say excess capacity or spare capacity to handle peak demands or growth. So the 3 wells that we shut down that I decided to shut down, so you can blame me for this. After the Navy contaminated Red Hill shaft, I shut down Halava shaft, then our Halava wells, and then later our IL wells. So those 3 remain off. And by the indications of how PFAS is spreading, they're potentially our greatest fear from the very beginning back in 2014 was, can the contamination move across Halava Valley from the Kapukaki side, Red Hill across toward Halava side? And until we know for sure, we're to keep those wells off. But that took away a large Halava shaft, a large source for urban Honolulu, so that spare capacity that was there to handle peak demands went away. So we had to take it up with other wells pumping harder. And we did see a rise in chlorides, saltiness of the water at Beretania wells, and we had to really cut back. And right now, by cutting back on pumping there, the wells have gotten really fresh, and we want to maintain that if we can. So developing new wells in the system to give us that breathing room or extra capacity to meet the peak demands or emergencies or operational problems is very important, and also to meet growth. There is a lot of discussion about growth on the island, the push for affordable housing, which we support. The need for affordable housing we acknowledge. We want to make sure that we do our best to ensure there's capacity to support these types of projects for our community and other types of growth that will come with transit-oriented development and other things into our future.
Going back to the map, I guess I was surprised that the Waipahu, Evakapale area weren't part of that demand need because of the rapid growth and also TOD, since that was mentioned for the Honolulu district. So I'm just surprised and wondering why that's the case. Because
we've known it's coming. There is some fairly significant capacity already there, and there is already planned capacity there. So those things together, we're not showing it here, but there is sources that are already planned out there that are coming in. It's just all already been programmed essentially. So which is why it's not creating a demand issue at this point.
Accept the notes from our last meeting. They went out ahead of time. You all had the chance to review them in detail. Any questions, comments, changes, corrections? We'll consider those accepted.
All right, so now we're gonna shift gears a little bit. Now we're going into the major findings. So we've been working on this update for about 2 years at this point, working through. So this is just trying to tie a bow on most things. I want to give you a roadmap as we go through, just so you know what's coming. 3 major things we're going to talk about. I'm going to talk about climate and condition assessment, and then Bill's going to come and talk about the sources and pumping side of things. You've seen charts like that, or relatively similar charts before, and we're going to tease through this one a little bit slowly because this is going to be kind of the layout on how we go through these. So the key findings here for climate. One thing we saw as we were going through the climate studies, working with UH on those, consolidating the information that's already been done. Climate variability is expected to increase, requiring continued monitoring of groundwater levels, recharge, and water quality indicators, so keeping an eye on things. This also means making production and distribution infrastructure more resilient to extreme events. So as we showed you, I think this one was a little over a year ago, beginning of last year. There's not real major changes in things like total rainfall that we're seeing, but there is fairly significant changes in the types of events. So they're more extreme events, and they're perhaps longer duration of droughts between those events. So seeing that variability increase. And as part of that, we need to be paying attention to the metrics that we use for aquifer health. We talked a little bit a minute ago about chlorides. We look at depth to water, of course, too. And is there things we need to change there? So the freshwater lens sits on top of the saltwater. So if with sea level rise, if the saltwater comes up, it's going to pull that lens up with it also. So we might see the water level coming up, even though the lens is either the same or maybe even getting smaller. Looking at the width of the transition zone from the freshwater to the saltwater. So thinking through the overall cycle here, we get rainfall falling onto the island. How might that change? Slight down, it's not real significant, depends on exactly which model you look at, but more variable and more extremes. The recharge, getting that water into the ground, we are seeing because of that more extreme reduced infiltration. And thus the runoff goes up. The water that falls on the island either runs off or it recharges, and a bigger storm results in more runoff. And then with higher temperatures, we get higher evapotranspiration, the evaporation from the ground and also from plants. And then loss to the ocean. This is actually one we don't see changing a lot. As sea level rise comes up, the freshwater lens comes up as well. It'll probably be up in some places and down in some places depending on the porosity of the rock, near the shore. But that's probably about the same as it will continue to be. Looking specifically at sea level rise, it does a few things. As I just mentioned, it may mask groundwater aquifer storage declines, the amount of water there, because we may see water coming up even though the freshwater lens might be getting narrower. Increasing corrosion of low-lying pipes. So pipes in the low-lying areas are now maybe underwater. And a couple of big operational things, making main break repairs in those areas more difficult, and the raising groundwater to the point where you mobilize subsurface contaminants. So this picture is showing us both of those things right now. I think this is Nimitz, it looks like, main break. So as a main break, here to repair it, this water is not from the main break. This is groundwater that's only, whatever that is, 3 feet below the surface. You can't even see the pipe because it's underwater. And this dark area is oil or contamination from the ground that's in there. So one picture that kind of shows both of those things. So it gets more complicated. How do you fix that pipe when it's under salt water? Now you're thinking more about, you have to be building cofferdams to repair pipes, things like that. So it can get more complicated. Adaptive management, we've said this over and over, but it's really moving forward. We're operating in less certainty. So what does that mean? We're going to do a quick definition. Adaptive management is a repeating cycle of assess, plan, act, monitor, learn, adjust, and go back around. We started this with all with you 10 years ago in the first loop with the 2016 master plan, and here we are in the second loop for 2026. So used when the future is uncertain and getting exactly right the first time isn't possible. None of us thought that the 2016 master plan was going to be the last one we had to do. It's about keeping it going. So climate uncertainty requires adaptive management, both from a capital perspective, but also from an operational perspective. And we need to be scheduling the investments with the actual need. Even there's things like climate, but there's also things like the TOD, some uncertain timelines, and making sure that we know what those triggers are and when we need to implement those programs. Looking at projections versus actual. We have projections out in the future of what we think is going to happen with demands, per capita demand, sources, climate. We need to keep an eye on if the actual values start trending outside of what we anticipated. When that happens, we need to reevaluate what we're looking at. And the overall takeaway here, we are seeing that groundwater availability may be significantly reduced by mid to late century under some of those climate scenarios. There's good scenarios and there's bad scenarios, but we need to plan for what the range might be. Again, climate, I think power reliability makes sense in here. The current backup power is sufficient under normal conditions. Board of Water Supply did get a few more permanent generators installed in the last few years, and there's a really pretty robust network. But the increasing wildfire risk and the increasing storm intensities are putting even more stress on the system when it comes to those. So the ability to operate without the mains power is becoming a bigger need. So that's probably, we're going to reconsider whether there's any more either portable or permanent generators that should be installed in some places.
Generators situated, are they regional to the different areas, or do they come from a central point? Because my concerns are if there's a episode or area that's swamped, is a generator positioned close by so that way it could service that area right away?
Yeah, so there's a fair number of sites that have permanent generators installed, so they're always there. And then the portable ones are stationed around at the different yards. And at least for any sort of anticipated event, they generally get moved out to where they might be needed. So if it's
maybe just a clarification. So the fixed generators are permanently constructed at different well sites, different pump stations. Beretania has a very large generator because of the number of wells there. The mobile generators, at the beginning of hurricane season, we kind of pre-deploy them to key sites, key wells that we anticipate if there was a event that impacted the whole island, we could turn on these wells, power them up with backup power, and try to support all the major medical facilities and as many people as we possibly can. But there is no ability right now to be able to provide 100% service coverage for our system based on backup power because we just don't have enough generators. So we pre-deploy knowing that it's going to be difficult to move them after the storm passes.
And you're working with HIEMA on that as far as?
Yeah, actually, we've been applying for a number of years now. Anytime a disaster occurs, there's something called typically hazard mitigation grant funds that are federal FEMA funds that we apply for, and we have they'll pay up to 75% of the costs, and we come up with a 25% match. So it's been a real good partnership. It does take a few years to go through the process, but HIEMA has been very supportive, and FEMA also.
At some point, it all comes down to resource allocation. So as an example, you go for those disaster mitigation grants, right? How do you allocate them or prioritize based on power generation or hardening the pipe that we saw broken because of salt water, right? Where is, right, convenience and safety to an extent, right? We're all told keep a certain amount of water, okay, versus mitigation for the almost everyday thing in some sense. And what is the algorithm or structure of reasoning you use to determine that kind of funding allocation?
The input from you all through this stakeholder process and what priorities you think and convey to us are most important are probably the critical element in making those kinds of decisions.
When we come out with and the ultimate goal of this effort, our 30-year water master plan is a 30-year capital program with a more detailed look at the first 10 years. But in there's an allocation by type of infrastructure improvement that we have to look at for pipelines being some of the largest number of assets we own, pumping stations, and also water tanks. And so those are all kind of allocated. And it's a nice colorful graph that we show that shows how we allocate it. But you're absolutely right, Pono. At the end of the day, Board of Water Supply, we're financially self-sufficient on people paying their water rates. So it's just kind of this balance, and you've seen it before, that between safe, dependable, and affordability for our customers. We got to be able to operate a safe and dependable water system, but we have to always keep in mind affordability. Pursuit of external sources of funds that don't come from our ratepayers is an essential part of what we're doing here, going after the federal dollars when they're available.
The algorithm, if you will, is the prioritization metrics that we went through a couple meetings ago. That's the map that we're going to use to work through that. All right, a couple meetings ago, my colleague Brian was here and talked about his inspections for climate resiliency of a bunch of the sites around the island, and he talked about how to mitigate potential disaster impacts. So this is here we're talking climate resiliency measures, which we're really meaning hardening against flood, wind, and fire. This, for the most part, can be done as sites are rehabbed. Every site gets, after a certain number of years, comes through and gets rebuilt and rehabilitated. And a lot of this can be done on that cycle. So a couple of the things that he mentioned that I'll call out: with a thing like a pump station, you need to have ventilation so it doesn't get too hot. So these openings, looking at hurricane louvers to block flying missiles, branches and things like that are wind blown, and also the rain, so it stops the rain from blowing inside. Ember resistant mesh from fire, so you don't get those embers to the inside where they can catch. Defensible space all around these sites, so that the fire gets knocked to the ground and cools before it gets to the site. Sealing up water intrusion paths that might be around the bottom. And then he also showed us some flood doors that are passive, that are just look like normal doors, but they when they close, they can handle a couple of feet of water on the outside of it. So all of those things are able to be done as sites are rehabilitated. And so we plan on just bringing that into the design criteria as we go forward and changing some of the standards. All right, so that's climate, and we're going to dive into the condition assessment. First, the overall, the system is manageable. The major, the R&R projects that were recommended in 2016, there's been significant progress on those, moving through those projects and getting them done. Those routine condition assessments are working. You know, we know how the system is changing over time. We haven't been blind for the last 10 years. So we do have access at some sites does remain a little bit of a challenge. There's, some of these sites are a long way away. They're in one-lane roads getting up to it. Vegetation that can blow over, roads that can blow away or flood away, and things like that. So there's a couple things there we need to work on. But overall, we're looking at risk reduction. You all probably remember that from 10 years ago. We're focused on risk, looking at those critical assets, the high consequence things, high consequence transmission mains. One that showed up, we'll talk about in a minute, is the exterior post-tension reservoirs. I'll explain what that means. Keeping up on the pump rehabilitation, and we're seeing treatment as potentially showing up as some new contaminants, new regulations. And then the last one is we got to be able to get to all of it. So workforce enablement, looking at project delivery capacity, really needing to expand that to be able to get the work out the door and completed. The first one, which is the biggest one, is going to be pipelines and main breaks, and I hate to say it's coming soon. So that'll be, I think the next meeting is we're going to do a bigger discussion on that, but we didn't want to shortchange it here. We talked about the scorecard. You all saw that. And probably the scariest number on that was the pumps out of service. There's about 33% of pumps out of service right now, as they're really the driver of that is there's the rehab projects got going. The pumps have been worked on, but getting them closed out and the pump station started back up has been the challenge. So that's currently the biggest operational risk. There's a big focus in the Board of Water Supply on getting that number down. So one of the things we've talked about with Ernie is looking at pump asset management, formally tracking those out of service pumps, making sure they're getting the ones unstuck that can. Talking reservoirs, so this is the external post-tension reservoir. A picture of it. Most of the reservoirs are traditional cast in place or concrete reservoirs overall. Those are continue to be in we say acceptable, engineers, so we can't say good for some reason, but acceptable. They're doing just fine, especially when considering their age. A lot of them are quite old, but the concrete reservoirs do well. So those are in pretty good shape. There's minor things here and there. They've got it spalling. You've got to fixing, vents and things like that, but nothing bad. Ones that we've looked at in this round of condition assessment are these external post-tension tendon tanks. So what does that mean? This is actually a tank. This was a concrete tank that was built in the 50s and 60s is when all these went in. 15 years after they were installed, they realized they were not quite holding up as much as they wanted them to. So this was a retrofit coming through and putting these cables all along the outside to increase the structural strength of that reservoir. So that was done in the 70s. So all that to say, I actually have gotten a lot of life out of these tanks. The issue is now we're getting to the point where things are really starting to go more quickly. So this picture is from the 2014 condition assessment, and this one is from just this last year, 2025. And this was probably the one spot where we did see aging faster than we thought it was going to go, and raised a little bit of a flag. The good news is there's only 7 of these tanks. It's not all of them, but it is something that is showing up as a critical rehab need. But overall, reservoirs are aging at a slow, consistent rate. They're manageable. They're repairable. So overall. Talk a little bit about electrical and controls. Again, most is in quite acceptable condition. This was all these condition assessments were done for all the pump stations 10 years ago. We've selectively looked at some of them this time. The biggest thing is electrical just they approach the end of their useful life. There is a certain lifetime for that type of equipment. And so they're all on a cycle over time. They just need to get replaced. So that's part of what's causing some of the pump outages. So they can be repaired and replaced during their routine projects. One thing that we have taken note of is really the indoor equipment is in much better shape than the outdoor equipment. That is, there's a strong capital reason to put things outside. It's a heck of a lot easier and cheaper when you first install it to not put a building around it. But we're really seeing really significant corrosion on the outdoor equipment, and just the ability to keep up with corrosion mitigation. So here's just a couple examples. These are pretty same vintage here. The MCC, these are old enough they have chart plotters in them, and they're okay. And then transformer outside is not looking so hot, So thinking about, all right, as we're planning for 50, 100 years for this equipment, some of it, maybe we need to be moving some of it inside as much as we can, especially when we start thinking about climate, fire, hurricanes. When you start adding all those things up, it might make some more sense to get things inside. Talk a little bit about water loss. So this is a definition. So American Water Works Association, Manual 36. So this is the National Water Organization. Gives us this manual on how to do water audits and loss control programs. So I'm giving you a little bit of a definition here because then we're going to talk about it on the next slide. But what I want you to understand is the difference between apparent water losses and real water loss. So an apparent loss is a little bit what it sounds like. It's a loss on paper. It's that you think you had a gallon of water, but you don't. So that can be due to things like meter inaccuracies. It could be data handling errors, that the meter is reading it right, but between the meter and the SCADA system or the historian or how it gets written down, something gets wrong. And an AWWA also puts unauthorized consumption in apparent. I don't like that because I think it's real, but that's how they define it, so we have to live with it. But they have unauthorized consumption there as an apparent loss. And then there's real. So real loss is things like leaks, valves that might be not sealed all the way, storage tank overflows, things like that. So you actually lost that gallon of water. We're really just starting down the path. This is going to be a relatively long path, but we've looked through and looking at where the water loss might be. The biggest problem right now is there's enough apparent water loss that it hides the real water loss. So when you have a big number, a big loss number, if a lot of it is apparent, you can't see where the smaller amount of real is. So what we're focused on right now is getting that apparent number smaller so that we can start seeing where the real losses are.
So
start fixing
Carl, as
those.
a refresher, I think the total combined water loss number right now is around 15%, pretty significant number. And the initial analysis suggests that it makes it difficult to tell how much is apparent
Yeah.
and how much is real. Is that where you're going?
Yes, yeah, exactly. It's we know that the apparent is probably the larger half of that at least. So when you have that much apparent loss, it makes it hard to see where the real might be and go find it. Doing some physical inspections, looking for leaking bypass valves or overflowing tanks, things like that. Some operational things that we can try to find. But then also testing meters, looking for meter inaccuracies there and those data handling errors. So following a value from the meter into the SCADA system, into the historian, where it's written down, making sure it's the same number the whole way.
In regard to staffing and whatnot, you know, when you look at all these plans and all the repairs that need to be made and whatnot, I mean, I think a lot of us that either manage businesses or whatever, there is such a difficulty in hiring people. And so, do you guys experience that too? And if yes, does that contribute kind of heavily to some of these major repairs that need to get done, or we don't really have an issue kind of a thing, and that's negligible for us?
We are experiencing staffing shortages, like everybody else right now. I think the unemployment rate is like really close to 2% for the state. So we're having trouble finding people. Overall, as an organization, I think we're at around 20% vacancy rate right now. But in certain groups, the vacancy rate is even higher. So I'd like to do more maintenance and upkeep, so you extend the life of the assets. But if you don't have enough people, then we're just basically just keeping the system running as long as we can. So staffing is a challenge, and you know, we're part of a civil service government system, so everything is really structured. A lot of times in certain positions, we can't even be competitive in the salaries. It used to be the benefits, used to be the attraction. When I started with the board, in government service many moons ago, you know, we had a good retirement system, and you know, you could have good coverage for you and your spouse. Over time, the legislature trying to reduce the post-employment obligations, post-employment obligations, they've reduced the benefits. So it's really made it difficult for us to be competitive. I do want to invite everybody that's listening and anybody here. We have openings at the Board of Water Supply right now. The positives, I don't want to be negative here. We have 21 days of vacation leave, 13 paid holidays, 21 days of sick leave. And there's still medical coverage for yourself. Doesn't cover your spouse anymore, but over time, if you work long enough, you can get coverage.
You briefly mentioned moving certain equipment indoors so that, you know, corrosion and whatnot. I guess my only thing with that is just, you know, for folks to just think about the cost of replacing things when they're indoors. So by way of example, like I may have mentioned before, I own an air conditioning company, and for aging systems that are indoors, yes, much more protected from corrosion, but when we have to replace these things, the owners of these buildings, they cannot even afford to replace the system because the cost to rip out the entire roof, because these systems are practically built into the building, it's extremely costly to do so, to disassemble. And then when you try to bring in the new equipment and install it, then the maintenance becomes voided. I mean, the warranties become voided, I'm sorry. Yeah. So, yeah, just food for thought.
But no, good points, because then from the get-go, we have to design these facilities so we can do the maintenance easily. For example, up in IAL, we have a well in a building, and the well goes deep into the ground, so you have to be able to pull the pump out. So when they built the building, they included a built-in crane in the building so they could lift the well pump out of the hole to replace it. But then the crane broke, so we had to figure something else. Or the other option is, can we remove the portions of the roof, lift it off with a crane, make it easy to pull the pump out of the hole, or pull the well pump and the motor out for maintenance. These are our challenges. Being in a building or in a structure also helps protect the equipment during hurricanes and from wildfire damage. So there's pluses and minuses, but really excellent points. Thank you.
So you have up there on the screen water losses. So I don't know if this is the time to bring it up, but on your first slide, you had a giant arrow heading into the sky called
Evapotranspiration.
that one. With regard to that, I know the Board of Water Supply works with the Forestry Department. They're doing a lot to try and increase the percolation and water tables. But my question is, are there other things that could be done? What about what about the landscape architect school at UH? What about a lot of the landscaping along the highways? What about how can we get replacements for things like guinea grass? Or maybe that's a great one, I don't know. But it seems like there's a lot of questions that could be asked about the plants, and maybe there's things that we could do that would have a long-term benefit.
Or, if you improve the forest health, it should be a better sponge. That's sort of the idea, right? So invasive species control, fencing, that kind of thing. And we do that through the watershed partnerships. But point being on the evapotranspiration, we are seeing some decreases in aquifer levels. And it could be because it's getting hotter, so we're getting more losses through evaporation and transpiration just because of the temperature increase. And that reduces the amount of water that can be recharged into the aquifer too. So it could be a combination of decreasing rainfall, increasing temperature, less recharge. We are seeing in some areas where we're not pumping that much and the water table is slightly decreasing. So we'll keep monitoring it, but climate change is real. So.
Yeah. And then Department of Facilities Maintenance is planning on starting a stormwater master plan here in the coming months, and I think looking at those opportunities for how to better recharge stormwater would certainly be expected to be a part of that.
Yeah, Carl stole a little bit of my thunder on demands earlier, but I wanted to include that as a key finding for the Water Master Plan. And remind you folks that we met, in a couple of the meetings that we've had, we presented that we looked at historical water use, right? And how it has changed both month to month and long term. And we looked at the different variables that might affect water demand. And we found that both climate and socioeconomic factors did contribute to demands, and water rates being the most significant. So just looking at the graphic, the blue line on the left is the historical demand, and when you factor in things like climate, it gives you sort of a increasing trend with that green line. And then when you talk about including that population growth that Carl mentioned of about 4%, 3 to 4%, that increases that demand. But when you include the downward pressure of rates, right? So as they increase over time, both historically and maybe in the future, that actually causes the demand to go down. And so the result of that is assuming that downward trend. Also coupled in with that is the reduction in water use on an individual level, right? Gallons per day that an individual uses is going down over time. So we'll be using that decreasing trend in water demands. And what that means is when we're looking at drivers for future source development, instead of rising demands, like in a lot of places, it'll be the groundwater sustainability and water quality concerns that will drive the need for future source development, not demands. So this is just a recap of the pumping capacity analysis and how that turned out. So don't need to go into too much detail here, but we learned about the several zones that are going to need some kind of either pumping capacity or operational improvements to contend with the need for more capacity in those zones. And just wanted to point out, we talked about TOD demands and how those will shift around the island. And using adaptive management, kind of seeing how those developments are implemented and how demand actually moves. We'll be looking at monitoring that demand increases to make sure that we can efficiently implement infrastructure to meet that expansion. So we also talked about future aquifer sustainable yield. In light of climate change, so we talked about the flows in and out of the aquifer and how those might change over time. But the sustainable yield in light of this climate change and how that's going to affect that water balance, it's definitely the largest uncertainty affecting future water supply reliability and adequacy. And significant reductions in sustainable yield may affect a number of things, right? The way pumping is distributed around the island, and it would likely be a primary driver for development of these new water supplies. The graphic on the right is actually a graphic done in a 2019 commission report, Seaworm report, and it looked at around Oahu and actually the other islands where the groundwater use reported, not only BWS, but everybody's groundwater use. What the groundwater use at the time was as a percentage of the sustainable yield of that aquifer. So in some of these aquifers, the current usage at that time was close to the sustainable yield, and those are shown in the dark orange and red. So just in terms of how much water you can get out of the ground, we talked about the different constraints or bottlenecks that can exist, bringing water out of the ground, moving it around. But just in terms of taking it out of the ground, these are areas that are already close to the capacity that you can pull out based on the sustainable yield. So in those areas, we'll have to monitor the usage, future usage, and make sure we can stay below that sustainable yield number. Also a plug, we mentioned watershed management plans, but those are a great tool to look at the balance of needs, sources, and projects that can help with demands within the different watersheds around the island. So we spent actually a couple meetings talking about the impact of chlorides. The upwelling as supply wells are pumped, pulling chlorides into the wells. And I wanted to just highlight as a key finding kind of the evaluations that we did both in 2016 as part of the last master plan and this time around. And so we looked at historical pumping rates and how it related to water quality data. Maybe some of you guys remember those charts that I showed with chlorides going up over time and how, in high pumping events or periods, chlorides can go up in places because of that upwelling, upconing of the transition zone. And so this time around, we looked at comparing those pumping rates with water quality over the last 15 years to identify at what rate historically water quality was stable. And then we looked at the rates that they were pumping at to say, okay, if you want to remain stable going into the future, then you should target these rates. What was interesting is in these boxes on the right, both in 2016 when we looked at 6 of the most critical supply wells, and in 2026 when we looked at the next batch, next 14 wells, the recommended pumping rate was only 1% less than what BWS had been pumping the 5 years preceding the analysis. So what that tells me is a couple of things, that based on the pumping that was being done, it's only a small change that needs to occur to remain stable, right? That's the first thing. The second thing is, we were looking at chloride issues that had built up over time. And some of these analysis in 2016, we went back to like the 70s or 60s in terms of the data we were looking at. And so the fact that it's only a small change means, compared to historical pumping rates, BWS had already been operating in a conservative manner in terms of water quality. So it didn't take much change to remain stable because they were already sort of doing that proactively. Besides those results, the takeaway here is just to continue monitoring this impact and make sure we are operating in the rates that contribute to stable water quality. This is a key finding on resiliency and source water protection, and I wanted to put a plug in for the great work being done for the state and for BWS's own source water protection plan. Proactive source water protection, right, helps anticipate contamination threats and sets up your response so that you can avoid a large impact on your system. And these efforts, like the source water protection, the statewide source water assessment program, and BWS's source water protection plan, they've actually we finished that up a year ago, almost, and it's already borne fruit because I heard they've already identified 2 of the abandoned wells that Ernie was talking about, and BWS is funding the disposal or the decommissioning, sealing of those wells. Now, contamination events may require source replacement or changing the way pumping is distributed, treatment, or production cuts. And these production cuts could create localized deficits even if the island-wide supply stays adequate. So that might require new infrastructure, and that kind of goes in line with the pumping capacity analysis that we were looking at earlier about how to move water around if we do lose sources. And then as a final takeaway, of course, evolving regulations, both in terms of the things we know and the things that we don't know yet that may come down further down the road, may necessitate additional treatment requirements. So we heard a couple of meetings ago, last meeting and the one before that, on what's going on with PFAS. PFAS has been detected in 16 sites and above the MCO at 4 of the sites at these supply wells. And so right now treatment is being designed and installed at 3 of the priority sites that were above MCOs. And this will happen within the next 5 years. And then longer term, the plan for the remaining sites that are at risk for contamination, 10 to 13 of them, will be monitoring trigger levels of contamination levels there. And if they go up and reach a certain level, then we'll be implementing treatment at those as well. We talked about alternative supplies last meeting. So as a key finding there, I think it's a great tool to improve resiliency and reduce dependence on groundwater. But we certainly know that it requires substantial planning, engineering, permitting, and infrastructure investments. So just as a reminder, we looked at continued conservation, increasing non-potable use, recycled water, seawater desalination, which is in progress. And we also, via that video that we looked at the possibility for potable reuse. And so those are all options for alternative supplies to help relieve our groundwater stress. And then one thing, we talked about climate and storms becoming more intense in the future. And so projects that increase the ability to capture those storm events and augment our groundwater supplies are going to be important. And one of the things that we've been looking at is a managed aquifer recharge project in Wanu Valley. And that'll take surplus stormwater and inject it into the ground for use as groundwater supply after some treatment. So those are the alternative supplies that we've been looking at.
Early on, you had mentioned our aquifer sits on top of saltwater and chlorine, and then in your presentation, the first contaminant that you discussed was chloride.
Mhm.
And I was curious, understanding the rise and fall, but my question goes to the cap rock. Is the cap rock kind of a given, or are there variables associated with the cap rock where it would let chlorine in or continue to be like a break wall to keep it out? Is it a constant, or are there variables associated with that?
So the cap rock, as it's understood now, is a feature that keeps fresh water in the island, right? But there is communication, ever so slightly through it. Like if you look at groundwater levels, close to the coast, you can see like tidal signals in it. So water does move, but for the most part, it keeps the fresh water in. There are areas, just because of the way the cap rock was formed, where it's not as thick as in other places. So that might contribute to some variability. But as we saw in our previous slide, based on our knowledge of how climate is going to change, the loss to the ocean, so through that cap rock, is going to be relatively constant over time into the future.
I sort of want to go back to what John Rapun had said, and that's a data center. So you had pictures of your facility as far as taking care of internal things, operations. But the thing that I wanted to point out is the military proliferates buildings and technology. Data centers are being established. And from what I've read is that a data center uses something like 300,000 gallons of water a day. And my concerns are the military can do a lot of these different things, and I don't know about accountability and how we adjust that. But the last thing I want to say, and give it back to Dave, is that many, many years ago, by St. Elizabeth Church in Aiea, there was the Navy Laundry Center that did cleaning for all the Navy's laundry for on-board ship and everything like that. And I really don't think that there was any remediation done. All they did was remove the buildings.
We'll start with the last one, the old IL laundry facility, because I serve on the Restoration Advisory Board for the Pearl Harbor, Kalailoa areas for the Navy's Superfund cleanup. They did do a cleanup there. There's actually still, I think, some actions still underway that they're using, I think, vapor extraction to try to get some of the contaminants out of the site. You have the laundry, and then there was like a maintenance building, I think, that was next to it on the Mauka side. There is a groundwater well that's still there, that was installed as part of that investigation. We've requested the EPA to require the Navy to now add that to the monitoring network for Red Hill, because it's a hole in the ground that you can get water samples from the aquifer. Regarding data centers, I happen to be on a discussion with utilities across the country just this week, and the subject was data centers. I think there was somebody from Nevada, southern Nevada area, Las Vegas, somebody from Colorado, Aurora, Colorado, and Loudoun, Maryland, I think it is, near the District of Columbia. Maybe the area that has the most data centers in the country, most density of data centers. And what was surprising is that I know the concerns were, and let me be clear, I'm not trying to defend data centers. I'm concerned about their water use, and if there is data centers proposed here, water use, and also they use a lot of power too. But in terms of water use right now, it seems like the data centers are starting to evolve to more efficient ways to cool. Mechanical cooling, systems that are closed loop, less, what they did in the past, I think, was just a single pass, use water to cool, and then dump the water. So they're becoming more water efficient, but we do need to watch them very carefully. Power is the other issue, though. They demand enormous amounts of power, depending on the size of the data centers. So they're putting the cooling closer to the chips, the computer chips, instead of trying to cool the whole building like they did, I think, initially. They're now targeting where the cooling occurs closest to the computers that are in the data center. But there are a few smaller data centers, I think, on Oahu. We've been checking on their water use too, but we haven't seen anything of the scale that there is occurring on the mainland. Maybe the other part of it is, Sherry left, but our cost for electricity is a lot more than the mainland, many parts of the mainland, so their power needs are still great. So to operate a data center here, it will be expensive in terms of power.
Going back to the slide with the one with the map with the red, green, and yellow. Yeah, I mean, is this a problem, the way where the red is, the green, the yellow, in terms of capacity and pumping? And
I'm going to ask Barry to respond to that question. This is based on the sustainable yield in those hydrologic units, which are, this map is actually from the Water Commission. It looks like the red is in the Nuuanu area, Nuuanu unit. And
Pololo, yeah.
And Pololo.
Yeah.
Okay.
And then the other one is Waianae, and one next to that is Makaha.
oh, okay. Interesting. I guess when I'm looking at it, because when I'm thinking about it, right, it's whether or not it relates to development. Because that's the primary user,
Yeah.
right?
Yeah.
And there's a reason why the other areas are green, right? Because there's no density, and that's fine. I'm not arguing that. I'm just trying to figure out, right, if it overlays, and then if that becomes a problem as we continue, like you talked about TOD, and we continue to concentrate population, because building, permitting, rezoning, right, nobody wants, they want affordable, but not in their backyard. So, right, it just has to stay in the urban core.
Yeah,
And then that becomes the price the whole island's going to have to pay. You don't want development in certain areas, fine, but there's a price to pay for that, and whether this is one of them.
You know, there are pluses and minuses to concentrating the development. The sprawl of infrastructure is less. You have less pipeline miles. You need it to serve more people, more businesses. I'll just ask Barry to maybe go ahead and respond. I may add to that. Go ahead, Barry.
This is 2016 data, so this is when Halava Shaft was operating, yeah. Now that it's off, we had to spread the demand across that even more, yeah.
So the red probably creep west.
But the slide before that, or the one after that, shows that is only a percentage off of previous, and that's just our operations doing a really good job of optimizing the remaining sources. So they had to spread that out, yeah. And it took a while. You have to, it's almost trial and error really, but they're able to balance it out. It took a couple of years. What we tried to do in Pololo, if you can go back to that, is reduce it with other sources. So we had a well in the one next to it, the Wailai West, it's under construction, waiting for a pump installation permit, but anyway, under construction, and that should take some of the load off of Pololo. The other thing is that we have the ability to move water. So we're moving water from Waipio into town to supplement or to make up for that loss of Halava Shaft. Yeah? And what that does is it reduces the amount of water that's available for Waipahu and Ava, and that all goes to Waianae too. So it's a domino thing. That's why we have 2 well projects, one Kalailoa in Eva and Kunia 4, but they're still not online yet. But when they are, we'll be able to rebalance how water is spread out, because this is one of the the metrics or what we are monitoring targets, percentage of, are we within our permitted use? Does it In the summer, it goes over, in the winter, it goes under. Are we hitting that? Can we reduce it somehow? And then, so in TOD, through Ernie's leadership, we've been trying to do more, like require on-site reuse. Like for instance, the Aloha Stadium redevelopment, the new Aloha Stadium Entertainment District. We are requiring them to flush toilets in the new stadium with Kalawao non-potable, rather than taking it from the potable system, yeah. And that provides more potable water for the mixed-use developments on the site. Because we have a meter. They used it for those mud bogs at the Olo Stadium, if you remember, and irrigation. So to maximize non-potable use, I'm trying to work on converting Alawai Golf Course off of our system. There are parks, Kapolei Regional Park, Kehi Lagoon Park, that is still irrigated with potable. But we have non-potable systems right there. So one of the ideas is, like we did with Kalava District Park, we converted that to Kalawao as well. So the conversion is slow because the park's got to, adjust their irrigation systems. But that with our water sensible efficiency programs, we're trying to reduce the demand so that it's with the eye of, not impacting or reducing the impact of our pumping in some of these aquifers that are right in the central core, yeah.
Yeah, not only flushing the toilets of the new Aloha Stadium when it's finally built with non-potable water, but also not a grass football field. We'll have an irrigation demand, so.
Thank you guys for the information. I wish I had as much, other agencies and utilities got as much clarity and a track record of 1% off and everything, so appreciate that. Are you thinking about the El Nino event that we're supposedly coming into in terms of lower rainfall and the storms and what impact that might have on operations?
I guess I'll say the answer is yes. It kind of keeps me awake at night times because I remember back in, I think it was 2015, at one time there were 3 Category 4 hurricanes in the Pacific at about the same time, Eastern, Central, and Western Pacific. So that's a concern. Right now the Western Pacific is getting hit pretty hard with typhoons. They call it typhoons there. But could that switch? We're a little quieter right now in the Eastern and Central, although there's something that's brewing out there in the Eastern Pacific. Will it flip later on in the season? And that's my concern. So our message to everybody is be prepared. Have your supplies and your resources already set up because I remember Hurricane Lane. Anybody remember Hurricane Lane? I tell you, we were just on pins and needles to the very last moments in the afternoon when the hurricane, which was headed north toward Oahu, and at one time was a Category 5, made this amazing left turn and didn't hit us. So by the grace of Keakua, we avoided that. But will we continue to be lucky? I don't know. Prayers and being prepared. Thank you.
Yeah, real quick, Barry, you talked about recharge happening in Nu'uanu. I was just curious, and since Palolo is one of those areas that's where the sustainable yield is being reached, can Ka'au Crater make a difference there? Could that be a recharge area? It's such a huge crater and right there, downtown.
Yeah, so the idea for Nu'uanu was to capture storm water, treat it, and then inject it into the aquifer as a sustainability type of strategy. Any kind of, I think it would have to be lined, and what Nu'uanu is in, Nu'uanu stream goes right through it, so it's usually filled with water. So, stormwater detention depends on, if you're not in a stream, it's going to require, heavy rainfall. You can do big projects like that or you can have tens of thousands of rain barrels and kind of almost, so there's a couple ways to actually address that. I know Kanikoa Schultz at Kaku'iwi is looking at more storage or, putting in retention basins. He's looking, around He'ia wetland, but he's also looking at areas in, I want to say the Waimanu Valley, along the stream there, and just putting in these detention basins that would then slow down the runoff and allow percolation instead of it running off. So having more of those types of smaller type projects may be more feasible than something really big, because we don't want another dam because of the regulation. But the concept of stormwater capture and recharge, especially in the urban space, I think is once they create that stormwater fee, green infrastructure will explode. What we're hearing from the community is this pent-up demand that they want to do green infrastructure. They just need some additional incentive to do that. Mm-hmm. And so if that comes into play, you're going to see a lot more of that. And if you're going to store it, then you should do it for non-potable use on your yard and also recharge too.
Do the findings that we presented tonight resonate, and is there anything that you feel like we've missed in these evaluations as we head into the process of developing the capital improvement program?
So I'm working on a project right now for sustainability for emergency shelters, and we're looking at AWG. One company that we found based out of Florida, they make a 4,000 gallon atmospheric water generator, and we're in talks with them to try and see if we can get funding so that way that could be utilized at one of the areas that is short on water. So when I get more information, I'll get back to you.
Great, thank you. Anyone else?
I'll just say, I don't think it's for this round of 2026, but I think, those pictures that you showed of Nimitz and how close the water table is and the pipes being underwater, given what's going to be happening with storms, like if you're looking at where pumping infrastructure needs to go and where overall, I think eventually we need to look more Mauka. And I don't know how much infrastructure we have in those spaces, like how much population you can take as things shift around the mountain, because it's going to get more expensive and more difficult to live right along the coastline from storm impacts and that underground water table changing. So it's probably too early for now, but I think in 2036 you're going to be talking about how to actually move where the demand is.
There's some massive issues, I think, ahead in the coming years as we look at the impacts of sea level rise and what that does to the ability to use low-lying coastal property and exactly the issues you're pointing out.
Well, these findings resonate with me, I guess. I'm not too smart about all this, but one thing I didn't hear, and I haven't been to a lot of the meetings, is renewable energy using photovoltaic and battery generation to power your pump stations. Has that been looked at? And I might have missed it.
Yeah, the board a few years back undertook a project to look at how to cost effectively implement energy projects that would pay for themselves. That work has largely been done, but I think as things go on, that's something that constantly gets looked at from an island-wide perspective.
Yeah, that was a project that actually Mark Chun worked on and helped be the project manager. Thank you, Mark. I know it was a challenging project. It was to become more efficient in our energy use, which is efficiency is always the low-hanging fruit that you want to go for first, probably the cheapest, then generation. Out of that project, I think we're down, we reduced our energy demand by 8 or 9%. In that range, and generation in terms of renewables, PV, about 3 megawatts at our various facilities on top of water tanks, over our parking lot. Powering pump stations a little challenging because of the amount of power needed to run these deep wells or large booster pumps. It would take a large amount of acreage for PV arrays to be put in place. And usually the stations are in not areas which is conducive for that. But it doesn't mean that we don't look at renewables maybe tied with backup generators too. And how do we keep our system operating when Hawaiian Electric has service disruptions, so that we can continue to monitor at least our entire water system.
Given the information that we saw today, are you guys talking to Department of Planning and Permitting and the city regarding where we should be developing and how we should be developing versus everybody just doing their own thing? And the only reason I'm asking is, and you know, I travel back and forth through Kapolei, I work down there and stuff. That area is growing extremely rapidly. Ho'opili is coming up like crazy. So in my mind, I'm seeing more need for water being placed in areas that potentially never had infrastructure, and that's going to exacerbate some of the areas that are already red on your map. So, you know, is there any kind of comprehensive discussion to figure out, given what we have going on the island, how best to address both issues? One, more housing, which we all agree we need, but number two, make sure that we're not putting more pressure on things that we're trying to manage today and then get whacked upside the head because somebody decides they want to put the 69,000 required houses right smack in the middle of Kunia.
Right. So great point, and let's start our next meeting with that.
Power to run the Board of Water Supplies pumps and so on. And Hiko's talking about distributed energy and conversation going on about that. Us crazy guys in Waiahole are talking about the possibility of generating power off the Waiahole ditch. And not just power that would be available there in Waiahole or Kahalua or wherever, but also the possibility of charging batteries that are lithium-ion batteries that are portable that can be moved to sites to be able to power facilities. So I just wanted to throw that out there.
This is our upcoming meeting. So we just had July. September is going to be a virtual meeting. It's September 17th. I feel like tonight we've been preparing you for like a final exam. You know, going through what we've covered in the course over the past few months. And the final is going to be the development of the CIP and the prioritization of that capital improvement program. So that's where we're headed. And the development of the long-range financial plan and the water system facilities charge, that's going to be the graduate seminar. So that's the path we're on here. So in person in October, and in November, we're actually looking at changing this to a hybrid meeting where the in-person part will be in the board's engineering conference room, and then we'll offer an online option. We've never done that before. We're going to try it in November because we really, this feedback and discussion is so important that I think as we rethought this, we're like, we really need as many folks here in person for that as we can. But we can't get Blaisdell. So we're going to try engineering conference room. We did one meeting there before. We'll be in person in January going through all of these plans, all the prioritization. Pono, get into the money. And we'll do a review in April and a final water master plan and summaries and looking towards the board's consideration of everything that you've contributed to here. So that's where we're going. Mahalo, have a great rest of the evening, and we'll see you soon.